So as usual, line 10, you replace it with your stuff, right? And we are going to use P data final. I think we used this before. Do you guys have it? I think we used it. P data final to 23.3. No? Okay, let's see. You see this data for linear regression. Yep. Yeah, data for linear regression, download it and place it in the folder. Did you guys do it? Okay, let's see. Oh, okay, I guess I don't have it. Okay, let's. You just try to follow me what I'm doing. So let me. I thought I had it. I did it like last year. Why it's not here? Just here, like what's going on? Okay, in this case, we just oops, do it usual way. So file, import data, import from Excel. And we have this what is P data final. We open it. And let's make this stuff numeric. By the way, I think I can give you extra credit for, let's say, 5 points. There is an R code which allows you to import data as numeric. Someone told me it recently, so we don't have to do it manually. So if you can figure it out, I can give you 5 extra credit points. And we don't do years. We don't need them for, at least for now. So just make it numeric, including year. And always save what you are doing. Don't bother, like year. Yeah, year is numeric. Yeah, but don't do years like y14, y15, y16. Don't do it. You don't need it, at least for this analysis. But how to make it like automatic? Or it's okay, let me take a picture. And like submit a screenshot, I will create an assignment. So did you guys import the data? Can we move on? Raise your hand if you need more time. Oh, okay. Raise your hand if you still need more time. Okay, let's wait a little bit. Yep.
Look at the data and everything, but why if I run this, like, it's all good, but I get this.
It doesn't matter. No.
I want to figure out the code and make this all numeric.
But it's again, you just do including year. You don't do another like 50 variables.
So you just use
Including year. From beginning, including year. They are like variables. Let me show it to you.
Wait, so we don't have to like turn.
You make numeric variables from case ID, including year. That's it. We don't need this for this analysis.
So up until year.
Including year. Could you please look at the screen, including this? So these variables must be made numeric, and that's it. Like,
What if I be more than the
it doesn't matter. It really doesn't matter. We are not going to use them. Do you need more time? Can we move on? Okay, let's go. Then in line 61, we make our data panel data. A panel data is a data which has multiple observations for same units for multiple years. So when we run it, and we look back at the data, Oh, okay. Click on P data. You see what's going on here? Here it indicates a link between observation and a year. Do you guys have it? P data. And this is different. You see, this data set is not panel. And this data set is panel. It links particular observation with a particular year. Then we run linear regression, and the code actually is pretty simple. So in line 64 or 74, first we create an object, as usual we do, right? Then we have this assignment sign, right? Then we have LM, which means linear regression, linear model. Then we have brackets. Inside those brackets, first, we have a dependent variable. It must be first, right? In this case, it's premium inflation adjusted. And I gave you like names for variables, so you understand it. Then we have this sign. I don't know what's it's in English, how it's in English. This sign. Stella? Tilde. Then we have tilde. Oh, let's. Then we have tilde. Then we have a bunch of independent variables. Post variable indicates whether or not term policies have been in effect. And this is how it works. So we look at the post variable, right? It's a bunch of zeros. It starts with 1, and 1 is in 2018, when Trump administration started implementing their policies in healthcare. And then again, for other observations, let's say Alaska, a bunch of zeros and ones, which start in 18. Then we have a share of young adults imputed, like how many young adults are present in a particular state. Then we have uninsured rate in 2017, before, like on the year when Trump became president. Then we have, and they're combined with a plus sign. And then we have INEA, income adjusted for inflation, average income in all the states. And then we have comma, and then we have name of the data set. So code for linear regression is like really simple. And in line 83, we get a summary of the results. Do you guys have it? Okay, so how we, when I ask you to interpret the results, you need to write a bunch of sentences. First, you need to interpret adjusted R squared. And the way you interpret it, this is the line and like write it down. Basically, this is percentage. So in this case, it indicates that 37% of change in dependent variable, in this case, it's premiums, is explained by independent variables in the model. So when I will ask you interpret the results, I want you to have this sentence. R squared, in this case, 37% of change in dependent variable, which is premiums in this case. When I ask you to run something, it will be different dependent variable. is explained by independent variables in the model. So this is interpretation of R squared. It's kind of decent model, not that bad. Then we need to interpret coefficients. So post variable, is it statistically significant or not? What do you guys think? And this is the p-value. Is it smaller or larger than 0.05? Which means, yep. And since there are like a bunch of zeros, it's statistically significant at 99% level, right? And then, so you have to like write down the sentence. Variable this has this p-value, it's larger, smaller than 0.05, it is statistically significant. Then you have to interpret coefficient. And coefficients in linear regression are percentages. So in this case, oh, like, so this would be like 64%, but it's like, oh, 64, 600, 6,000. What is after 1,000? 6 million? So 1,166,000. It's like too large. But yeah, but this is percentage. So let's do like simpler one. Let's do actually, you know, like other way to interpret it only in this case. Since our dependent variable is premiums and premiums are dollars, right? So in this case, we can say implementation of Trump policies when they started, right, led to increase in $166 in premiums in states. In this case, it's kind of easy because we have dollars, we know the value of our dependent variable is dollars. And it kind of makes sense, like Trump policies are always bad for healthcare. So once he started implementing them, it led to increase in premiums. People started paying more for their health insurance. Kind of makes sense. Another variable is, let's see, a share of young adults imputed. Is it statistically significant or not? What can you say about this p-value? Yeah, it is statistically significant, but it's like, what is it? And here it gives you like, what is it? It gives you hints. So this 3 stars indicates significance at like, what is it? More than like 99%. 2 stars indicate significance at like exactly 99%. And 1 star, remember, this is the p-value. This is the threshold. Indicates statistical significance at 95% confidence level. So in this case, we can say that variable share of young adults imputed is statistically significant at 95% confidence level. And the interpretation of coefficient, it is negative, right? So it means increase in share of young adults leads to decrease in premiums for like $4,000. And it kind of makes sense. And the reason is younger people are usually healthier on average than older people. So if in a particular state, we have a larger share of younger people in a state, it means overall, like in the health premium pool in that particular state, people would be utilizing healthcare less on average. which lead to a decrease in premiums. Yep.
The data of money, you don't have to change that into percentages?
Yep. What if your dependent variable is like dollars, money, you interpret your coefficients in money terms. But if it's like something else, you do percentages. Any questions about interpretation of results of linear regression? Yes, no, maybe. Again, first you do R square, and it is a percentage. In this case, 37% of change in premiums is explained by independent variables and models. Then you interpret significance of coefficients, and then you interpret coefficients. And one important thing, you don't interpret coefficients which are not statistically significant. You just say p-value is this, and no need to interpret coefficients which are not statistically significant. Only statistically significant coefficients must be interpreted. So I could imagine you run a model and there are no statistically significant coefficients, so you just say it. That's it. And then we are checking for heteroscedasticity. And to do it, we create an object. This function allows us to plot residuals. Resid is a function to plot. And again, whenever you do, if you don't know a particular command, you do this question mark and type a command. And then you can read something about the command. Okay. And then we plot in line 93, we plot residuals, error term. Obviously here, errors are not random, right? Which means we do have heteroscedasticity. So when you plot the results, you do like, I don't know, hashtag since errors are not random, we have heteroscedasticity in the model. This is how you interpret it. That's it. I typed it. If errors are not, since errors are not random, again, you just compare it with this stuff. Random, homoscedasticity, not random, heteroscedasticity. So in this case, when you plot residuals after running your regression, you see like, are your errors random or not? And then you interpret whether or not you have heteroscedasticity in the model. That's it. Any questions? No questions? Yep.
So checking for heteroscedasticity, what does that mean?
If you have, if your errors are correlated with your independent variables, and remember when we discussed assumptions of linear regression, your errors must not correlate with your independent variables. Yep.
So you have to say that.
Yep.
Do we have to say like this specific?
No, you just say we have heteroscedasticity. That's it. Whether or not you have it. And in terms of like research, if you have it, you cannot get published, basically. You have crappy model. Any other questions? For homework, I will give you a data set. It will be different from this. You will need to run linear regression. And I think I even give you like your variables. And so you will have to run regression and interpret the results. And hopefully you know how to do it. That's it. That's